With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's start the question. Given for hydrogen atom, nu bar is equal to RH into 1 upon N1 square minus 1 upon N2 square. Select the correct options regarding this formula for Balmer series. So, as the statements have been given, N1 is equal to 2. Ionization energy of hydrogen atom can be calculated from the above formula. Lambda max is for N2 is equal to 3. And if lambda decreases, then spectrum lines will converge. So that is your fourth statement. Okay. Now, in that case, in fact, this 1, 2, 3, 4 needs to be considered as A, B, C, and D because we have been given options in that form. Okay, fine. So let us analyze. The very first thing, when we say it's the Balmer series of the hydrogen spectrum experiment, it indicates that the N1 value for Balmer series is always going to be 2. Okay, so that means the first statement is absolutely true, right? Now, after that, we can say that obviously N2 would start from 3, 4, 5 and it will continue to infinity. Yes. So in that case, whenever we calculate nu bar, it's equal to 1 by lambda, which is equal to RH into 1 upon N1 square minus 1 upon N2 square. Okay. Which means that the longest wavelength would be calculated when N1 would be equal to 2 and N2 would be equal to 3, the immediate one, isn't it? Yes. So 1 upon the longest wavelength would be equal to what? 1 upon N1 square, or otherwise 1 upon, let me put the direct value. So it's going to be 1 upon 2 square minus 1 upon 3 square. So this would give me the longest wavelength. If you increase the N2 value, obviously you would have a decrease in the wavelength, yes, and definitely you know well that the difference would be larger, isn't it? Yes, and hence the reciprocal value of it would also be a very, very small value, isn't it? So this one would give us the perfect value, yes. So which means lambda max is for N2 is equal to 3. This is also correct, yes, the third statement. Now comes in the second statement, which says that ionization energy of hydrogen atom can be calculated from the above formula. Now that is not really possible because obviously ionization energy cannot be calculated. We can calculate nu bar, that's the wave number. We can calculate lambda value, but not ionization energy. So this is totally incorrect. The second statement, we cannot calculate it. Yes. Coming down to the fourth statement, if we go to see, if lambda decreases, then spectrum lines will converge. Now, as I told you, the longest wavelength would be between the value 2 and 3, isn't it? So those are the consecutive lines or the levels which we are talking about. So that gives me the longest wavelength, which itself means that as we go on increasing the N2 value, the lambda will go on decreasing. So obviously it's clear from that scenario itself that the spectrum lines won't converge, obviously. Yes, they would be far away from each other, right? The levels will be different. They will be quite far away. So which means the fourth statement is incorrect. So altogether we are having the first and the third statement which goes true for the Balmer series. Yes, and hence we mark option number A and C to be correct, which reflects in option number 3. Yes, in fact this was A, B, C and D. So A and C is correct and hence we mark option number 3. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.